Hey folks, how's it going? This is Mr. Murray coming to you with a do now for Course 1 CP for Tuesday, May 19th, 2020. So in this do now, we're going to kind of continue on with what we've been working with. We're going to do a little bit of practice on converting to standard form and intercept form. Again, if you're stuck on any of this, you can find additional practice for converting to standard form at expand.willnot.fail and for converting from to intercept form at factor.willnot.fail. Now, here, the problems you're going to see me drawing from today would be considered the hard problems. And for the factor, they're going to be the easy problems because we're still working our way up there. All right, but that's what we're going to do. So please take a second, pause the video, convert the first to standard form, the second and the third to intercept form. Then when you're ready, unpause, and you can see what I got. All right, here we go. So first to convert to standard form. Now it's important to recognize that this right now, as is in vertex form. So I need to start by doing my PEMDAS, and that means I need to start by expanding x minus 22. So let's see what this looks like. X times x is x squared. X times negative 22 is negative 22x. X times negative 22 is negative 22x. Negative 22 times negative 22. Geez, what's that? That would be 484. And that's something you'd probably want to use a calculator for. So what I get is 7 times x squared minus 44x plus 484 minus 5. Then all I have to do is distribute. So I distribute in, boom, boom, boom. So I get 7x squared. Now here, be careful with your signs. Be careful with your signs. Minus 308x okay, and again, I'm using a calculator for this. I'm using a calculator for this. Okay, so what I did is I'm just going to double check. I did 44 times 7, 308, 484 times 7, 3,338, and then you minus the 5, and you get 7x squared minus 308x plus 3,383. Now look, here's what I want you to know. Look, the numbers look big. Don't get worried. Don't get scared. Don't get wrapped up in the numbers. The numbers are not themselves are not what matters. What matters is the process, and the process has remained the same. We're boxing the part that's being squared by multiplying something by itself. We're then distributing the number, and then we're subtracting the a, right? And then we're subtracting the number on the end. We're just simply doing what we've been doing since elementary or even middle school, and we're doing PEMDAS, right? We're just doing order of operations, the exponent, the multiplication, the subtraction. Okay, so we'll continue to work at it, but at the same time, we're also starting to move on. So if this is something you're struggling with, please make sure you're seeking me out for open office hours Tuesday morning, or I suppose the Google Hangouts every week. Okay, now I got to convert to intercept form. So remember, the intercept form is box in reverse. So instead of starting with the outside, so I think of this almost as like question and answer. So the question is, if I give you the length and the width, can you tell me the area? Here I'm giving you the area. I'm telling you that when you're done, and I should use n, I'm telling you that when you're done in the very end, you get n squared minus 17n plus 60. Okay? So I need to figure out, well, what was the length and the width if this was the area? So remember the common patterns. What you know is n squared goes here and 60 goes here. Okay? You also know a few other things. You know that you have an n on the top and an n on the left, which is going to help you out a good amount. Okay, and then you also now need to figure out how to multiply to get 60. So what you know here is that you have a positive and a positive, or a negative and a negative. And the reason is because you need to multiply to a positive number, and only two positives or two negatives do that. But to go further, you need a negative, because if you add two negatives, that's the only way you get a negative number. Okay, so what I'm looking for is two numbers to multiply to 60, both of which are negative, and that's negative 12 and negative 5, because negative 12 times negative 5 is positive 60. If I plug in negative 12 here, I get negative 12n, and here I get negative 5n, and then when I combine like terms, I get the answer I was looking for. So what I report as my final answer is n minus 12 times n minus 5. Okay? All right, now I'm going to do my last one here. So it's going to be the same idea. Let's start with our box. All right, and set that up 2 by 2. And I know you might be asking, why is it always 2 by 2? And the reason is because whenever you're going to be breaking one of these things down, the biggest power of the variable is gonna be less than the biggest power of the variable in the original expression. So that's like saying, if I need to factor and the biggest power of j is j squared, then the biggest power of j in my answer is going to be j to the power of 1, because it's got to be less than 2. Okay, and so that's why I've got 1 for my j to the 1, and then this would be like j to the 0, because when you just have a number, right, there's no j there at all. Okay, so again, I set up based on what I know. I've got my j squared and my negative 54. So I put my j up top and I put my j to the left to get my j squared. And then I remember that, look, I'm working with a negative that I'm multiplying to. And so that means I need a negative times a positive to be able to get a negative. The other thing I'm going to make note of is that my negative number, or my positive number rather, is going to be farther from 0. And that's because I'm going to be adding two numbers, right? But in the end, I end up with a positive sum, which means the positive number was farther from 0 because the negative wasn't far negative enough to be able to pull it into the negatives, right? To be able to pull that sum so that it would be a negative number. So now I got to think about, what can I multiply to get 54? So I could have 1 and 54, because 1 goes into everything. I could have 2 and 27. I could have 3 and 18. I could have 4 is not going to work because I think you get 52. 5 won't work. 6 will work because 3 and 2 both work, and you get 9 because 6 times 10 is 60. Let's see. 7 will not work. 8 will not work, and then 9 loops back to 6. So I believe I see it here. We're going to need a positive 18 and a negative 3. And remember, because the numbers in front of j are both 1 in this case, it does not matter where you put these. Okay, today we're going to be moving forward into a new type of factoring, and we're going to start looking at, well, what happens when the number here is not 1 anymore? How does that change the problem? And the answer is, honestly, not very much. Because the thing is, the box still works. We're just going to have to change up how we think about the box. We're going to have to think about, well, if I put a 2 in front of the j squared, then not only do I need the j and the j to get a j squared, but I need a 2 and a 1 to get the 2 in front of the j squared. But then, once I have a number in front of the j's, I have to remember that when I set up my other two numbers, one of them, for example, if I put a 2 in front of this j, one of these numbers would be getting multiplied by 2, and the other would be getting multiplied by 1. And that's why the multiply 2, add 2 trick doesn't always work. Because when a is not 1, it's just not that simple. All right, so more to come in today's lesson activities, but thanks for watching. Hopefully you're able to get these right. Best of luck. Don't forget to love math. And remember, You can do it. Thanks for watching.